Alright, so now that we know how to work with one quantitative variable, we're going to talk about comparing a quantitative variable between two groups. So in this set of notes, you're going to have a quantitative variable, and then you're going to have this categorical variable that creates the two groups. But this categorical variable can only have two options, that way there's only the two groups. And so we'll sort of see this with every example that we're doing in this set of notes. There will be a quantitative variable with a categorical variable with only two options to go with it. So to start this, we're going to look at an example to see if people dish out more ice cream and they have a large 12-ounce bowl compared when they have a medium 9-ounce bowl. It's sort of a psychological example here. See if your mind is played by the bowl size. So who our population is basically people who dish out ice cream, so we'll call them ice cream dishers. What we're measuring on this ice cream disher, well, one thing that we're measuring is their amount of ice cream that they put in the bowl, which is going to be a quantitative variable. And then we're also going to measure which bowl, is it the medium or the large bowl. So that's going to be a categorical variable since there's only the two options. Why are we collecting data? Well, we're trying to see if they put more in the large than they do in the medium. How are they collecting this data? They haven't really told us much as usual, but it's even of more importance here. So we really don't know anything about it, but it does really matter. And we're going to start by talking about that and seeing how this really does make a difference on how they're collecting their data. So what we're going to talk about here is what's called independent versus paired samples. So we're first going to start by defining what a paired or dependent sample is. So a dependent or a paired sample is one where there is a specific pairing from the first sample to the second sample, and these elements are expected to be related on the variable of interest. So that is, their measurements are expected to be more similar than just random observations. So what I mean by this is, for an example, if I want to see how happy people are in their marriage and I ask them to rate things on a scale from 1 to 10. If I specifically ask a husband and his wife, I expect that their numbers should be pretty similar because they're in the same marriage. First, if I just randomly sampled a man who happened to be married and a woman who happened to be married, but they're not married to each other, I don't really have this expectation that their numbers should be somewhat similar. So that's what I mean. So its measurements are expected to be more similar than just random observations instead. An important thing before we get into deciding if things are independent versus paired is notice I didn't actually define independent. I mean, independent is when it's not dependent. And so what we do is we always assume they are independent until we know otherwise. So if we don't know of a reason that they're paired, we're going to assume that they are independent of each other. So we're going to go through 4 setups to decide if things are going to be dependent or independent. So with our first example, we're comparing the price of items at Kroger and Walmart. So notice that we have this quantitative variable of price. Then we also have which store, Kroger or Walmart. So that's a categorical variable that has 2 options, Kroger or Walmart. That's why we're comparing a quantitative variable in 2 groups. We sample 20 items from Kroger and record their prices. We then sample the same items at Walmart and record the prices. So when I'm trying to decide between independent or paired, this is usually what I do. I sort of create, here's my 2 groups, so I have Kroger and I have Walmart. And so I walk into Kroger, I'm going to randomly choose an item, and suppose that I choose to sample a box of Oreos. Now when I go to Walmart, is there a certain item that is matched to this Oreos at Kroger? Well, it said I had to sample the same item, so once I have Oreos at Kroger, I have to also get Oreos at Walmart. So what our example is going to turn out to be here is it's going to be paired or dependent because we're sampling the same items at both stores. Now notice, I'm not saying that they should be the exact same price at both stores. But if, the price of Oreos at Kroger is $3, I mean, the price at Walmart isn't going to be $12. Like, right, they're going to be somewhat related to each other. They should be somewhat similar to each other because it's the exact same item. So I got Oreos here. I had no choice when I walked into Walmart. I had to get Oreos as well. So there's this pairing going across for each of our items here. Now, if I look at my second example, we want to see what effect gender has on an exam average. So for each student here, I'm getting their exam score and their gender. Alright, so exam score is going to be quantitative. Gender is categorical. Only two options, female and male. I randomly sampled 20 females and got their average on the exam, and 20 males and got their average on the exam. So my two groups here then are the women and the men. And so if I sample a woman, and let's suppose for a moment that I have to sample, and I chose Mary as one of the girls I'm going to sample. So now we're going to go over and see if I need to sample something in particular when I go over to the men. Well, I know it has to be a guy. But is there now a certain man that I must sample that's matched with Mary? Nope, I can really sample any guy I want. Right, Mary does not have a specific pair or a specific match. That's a man that goes with her. That has to go with her. And I have 20 men and 20 women. I can make pairs, but there's not a certain man that has to go with a certain woman, or vice versa. So since there's no known reason to pair them up, this one is going to be independent. Because at least from what I've gotten, right, there is no known reason to match a certain man to a certain woman. So that's our first two examples, one where it's paired and one where it's independent. Now there's two more examples on the next page. I generally do strongly suggest trying those two examples on your own before you watch the rest of the video, because this is sometimes something we struggle with, is just having to decide between paired and independent, and it does make a difference in this set of notes. So go through example 3 and example 4, come up with if it's paired or independent and have a reason as to why, and then unpause your video and watch to see what the answers should be. Alright, so hopefully we've already worked both of these problems. So we're trying to see if gas with ethanol gets worse gas mileage. So we have 10 Hyundai Sonatas. 5 are randomly chosen to get regular gas, while the other 5 get gas with ethanol. Each of them are driven for 250 miles under the same conditions, and the gas mileage is recorded. So our two variables, we have the gas mileage, which is going to be quantitative. We have the categorical variable, which gas type, is it regular or is it with ethanol? So that's kind of why we're comparing a quantitative variable in two groups. So if I create my little groups here, I have the regular gas and the with ethanol gas. And so let's suppose for the regular gas, I sample my car. And let's just pretend I have 10 Hyundai Sonatas. I'm just going to number them 1 through 10. And suppose car number 3, I choose to get regular gas. So now let's go over to the with ethanol group. Well, I know I'm sampling another Hyundai Sonata, so I'm going to draw my attempt at a car here. But now that I chose car number 3 to go over here as the regular, is there now a certain car that has to get the with ethanol? Any of the other 9 cars could be the one that gets with ethanol, right? There's not a certain car that has to get this. So this one actually is independent. And let's write out the reason why, and then I'll explain a little bit more. So there is no known reason to match a certain one with regular gas to a certain one with ethanol. Now this is one that sometimes we think is paired. I'm going to explain the most common reasons people think it's paired and explain why that actually is not making it paired. So here's one of the reasons people think it's paired. I have 5 that get regular gas, so the other 5 get with ethanol. So once I have those 5 chosen, the other 5 have to get the other. And this is where it's kind of important to understand kind of picking them one at a time. Because if I have 5 in each group, do I have to match a certain one from each group together, or could I match any of them from each group together? So my similar example that I come up with students here, so right, all 10 cars are the same. And so I usually joke that, you know, when my son first gets a new pack of socks, it's easy to do laundry, right? Because I mean, I have 10 pairs of Hanes socks that all look exactly the same. And why it's nice when I do laundry is I can put any 2 of them together to make a match. Now I'm using match here in quotes even while I'm talking here in my office by myself, but it's not really a match, right? There's not a certain sock that has to go with a certain sock. I can put any of them together. That means they're independent. As I pick up one, I can pick any of the remaining ones. There's not a certain sock that has to go with it. It's the same idea here. Once I pick one car, there's not a certain car I have to pick up now that goes along with it. Right, another reason why sometimes students will think it's paired is they're all driven under the same conditions. This is again really just to make sure that when I'm recording this gas mileage, I didn't drive them different. So all 10 cars are driven the exact same. Right, it's not like I have some being driven differently here and some being differently here. This one is independent. There may be questions on that one when we start class together next time. All right, for number 4, we're interested in seeing if Ally helps people lose more weight than a placebo. So right there I'm already reading my 2 groups. I have my categorical variable of what they're taking, which is Ally or a placebo. I took a random sample of 50 people and found a match that is similar to them in weight, gender, cholesterol, etc. One will get the Ally and the other one will get the placebo. They all follow the same regimen for 8 weeks and we record their weight loss. So our 2 groups is the Ally medication and then those that are taking the placebo. So suppose for the Ally group where I'm randomly choosing my 50 people and I happen to choose Sally. So Sally's a girl, as you can see from my little skirt I put on her here so far. So when I go over to my placebo group, I know I have to match girl, right? I mean, it has to be the same weight, gender, etc. So there now a certain person I need to find. Well, there really is. I have to find someone who is Sally's match. It's not the same thing as, you know, finding Sally again, but I'm finding someone similar to Sally as I possibly can. So this one should fall into our paired options because for each person sampled, we find a match. Yeah, they're not exactly the same, but they are similar to each other. Therefore, their numbers should be similar than just randomly picking 2 people. So I'm hoping that helps explain the difference between independent and paired. Now we're going to start talking about paired samples first. And the main reason we're going to talk about paired samples or dependent samples first is because they're generally a little bit easier to understand because the math that we do with those is very similar to the math that we do in the previous two sets of notes. So the first thing I want to talk about is what we're talking about for paired data, and then in class we'll jump into our first example. And so here's an important thing. So for paired data, I don't really care about the actual values that I get. We are really interested in their difference. So suppose that xi1 and xi2 have something in common with respect to how the sample was obtained. So like, for example, this might be Kroger and this is Walmart, right? So I'm getting the same items at both stores. Then let this di, which is the difference, be defined as xi1 minus xi2. Alright, so let's explain a little bit beyond this all mathy notation. So suppose for a minute that 1 is going to represent those that were from Kroger, and 2 is going to represent those that were from Walmart. And so my order of subtraction is going to be 1 minus 2. So I'm going to do Kroger minus Walmart. Now, one of three things can happen when I do this. I can get a positive number, I can get a negative number, and I can get 0, which each tell me something very important when it comes about Kroger and Walmart. Now, so here's why again I'm calculating that difference. So let's suppose that at Kroger, my Oreos were $3. And at Walmart, my Oreos were $2.50. Now, I don't really care about the actual price. Really, I really worry about is how much more am I paying at one store compared to the other store. So, right, if I'm going to buy Oreos, I'm going to buy Oreos. I just want to know how much more money it's going to cost me at one store versus the other. So if I get a positive number, I do Kroger minus Walmart. That means my first number had to be bigger. So if I get a positive number, that tells me that that item was more expensive at Kroger than it was at Walmart. Whereas if I get a negative number, that means my first number is smaller and then my second number is bigger. That would mean that that item was cheaper at Kroger than it was at Walmart. And finally, if I were to get 0, the only that's going to happen is if those two things are exactly the same. So that would mean that whatever price I was paying at Kroger for that item was exactly the same price as I would pay for that item at Walmart. So what I'm going to be working with is, again, not all these prices of items, but I'm going to be talking about the differences in prices. So again, instead of like having it's $2.50 and $3, okay, I'm going to get, it's a negative 50 cents. So it's 50 cents more at Walmart than at Kroger. Then these are the numbers that I'm going to be working with. And from there, I'm going to calculate some numbers. So we have some different symbols, but similar symbols to what we've seen before. So let's talk through these symbols. So D bar looks a lot like Y bar, right? Remember, if Y bar was our sample mean or our sample average. The D is really there to emphasize that it's the sample average difference. So for example, it would not be how much money I'm spending, it's that average how much more money am I spending at one store versus the other. So it's that difference, average difference in prices, not the actual prices. On that same note, SD is very similar to what we've seen before as this S. S was our sample standard deviation. The D, again, is just there to emphasize is the standard deviation of the differences. So I'm working with these numbers up here, again, not their actual prices. N we've seen before, but N is defined maybe a little bit different here. So it's the number of pairs or differences I have. So for example, if I have 20 items that I got at Kroger and 20 items that I got at Walmart, my sample size is actually just going to be 20. Because I have 20 pairs that I'm working with. Mu D and sigma D are just sort of like our population mean difference and our population standard deviation of the differences. So again, the reason why that D is really there is to emphasize we're not talking about just that quantitative variable in general. It's that difference between the two. And you'll see me emphasize that with every example that we're going to do. In the first example we'll do in class next time, we'll be looking at that ice cream data set that I started with here, and we'll actually interpret everything to see if that helps make sense of what all these symbols really are.